Hi everyone. Okay, I wanted to do a video on DC motors, and they were mentioned in the chapter, I think 14. We were talking about blower motors and windshield wiper motors, and they were talking about controlling the speed of those motors either through resistance or pulse width modulation. Um, I'm going to just show you how the voltage affects the RPM of a DC motor. And that's what happens when they're running it through a resistor. They're actually dropping the voltage, and if they want full speed, then they just bypass the resistors. So anyway, I have here a little electric motor for actually an electric airplane. It's one of my hobbies. I have it hooked up to a propeller, and I also have a photo tack here. So some of this is hobby. This is what I used in the industry. We used to have to check the speed of servo motors and DC motors, AC motors to make sure machines were operating properly. So combination industry and hobby here. The DC motor is a permanent magnet. It's basically what you'll see a lot in automotive industry. Not in the electric cars. They're actually using three-phase motors, AC current, which that's a whole another lesson. Anyway, I have Pico hooked up here so we can monitor voltage, and I also have digital multimeter here down on the lower right corner. So let's just look at the operation of this motor. Let me let Pico get here. Okay, right now I have it hooked up to a 7.24. Okay, so you saw it was about over 8,000 RPMs, 8,900 RPMs average. I wanted to capture that signal. I'm going to capture this signal here so you can see what I want to talk about. Let me reset Pico. And I'm going to knock myself out here. Okay, it went over range, but you can see basically the DC voltage. You see this little drop off right here is what I wanted to talk about. Normally if I just shut the switch off, that should just drop off, but because there's some momentum on that propeller, the motor's continuing to uh, slow down instead of just stopping. And as it's doing that, it's producing some voltage. That's why you see the voltage dropping off slowly. So in the electric car, which makes it really efficient, is we take that voltage and we switch it back into the batteries. So as the car is slowing down, we can actually start charging the batteries from this, what we call regenerative braking. So at the same time, it's braking the car, slowing it down, and also you're charging your batteries. That's what makes electric cars efficient. So I didn't want to knock that clear out. I'll lower it back down. I'm going to hook up a battery pack with less voltage just to show you the difference in RPM. I lost my battery. This is a 4.8. You'll see that on the readings it's less than 4.8 because these motors pull a lot of amperage, and they only run about 5-10 minutes on about 10 minutes on full amperage on a battery pack. So that's the way they were designed for hobbies. So that's why you're going to see less voltage. So let's take a look at the RPM on this one with less voltage. So you saw there was about 6,400 RPM. Voltage on the multimeter pretty much max. Whoops, I lost my signal. Let's look at that one more time. So a little over 3 volts on a 4.8 pack. Again, the amperage draw is excessive. So, and again, we see that deceleration, that regenerative where that motor is actually producing voltage from the momentum of that propeller. So same thing, but it shows how the RPM can vary just through changing your voltage, either by using resistors to knock the voltage down or some kind of electronics to control the voltage. So that pretty much ends this session. This one here, I want to do a one on pulse width modulation that shows how you can control the speed of a DC motor through that way. So I'll do that in a little while here. Thank you.